Have you ever stopped and wondered how your phone just knows the fastest route home? Or how a city even decides where to put a new park? Well, the answers are written all around us in something called geographic data. And today, we're going to learn how to read it.
So let's just start with something we've all experienced. You're driving and your phone tells you there's a traffic jam 5 miles ahead. How? How does an app know the best time to go to the grocery store? It honestly feels a little bit like magic, right? But it's not. The secret is a constant, invisible stream of data that's being collected all around us all the time. In this explainer, we're going to break down the architecture of that data. We're talking how it's gathered, how it's analyzed, and how it's quietly shaping the world you live in every single day. All right, first things first, where do we even begin? Well, all this geographic information basically boils down to two fundamental types, and the easiest way to think about it is this. It's the difference between cold, hard numbers and personal stories.
Now, the official terms are quantitative and qualitative data. Just think of it like this. Quantitative is about quantity, the how many. Qualitative is about quality, the how and the why. And to really understand a place, you absolutely need both. So let's dig into this a little. Quantitative data gives us those objective, measurable facts. Things like census counts, air quality readings, hard numbers. But that data can tell you that a population is shrinking, but it can't tell you why people are leaving. For that, you need qualitative data. You need the stories, the interviews with residents, the cultural observations. You really can't get the full picture without both sides of that coin. Okay, so that's the what of the data. But the next obvious question is, who's collecting all this stuff? And this is where it gets really interesting, because the collectors are operating on completely different scales. On one end of the spectrum, you've got what you could call the individual detective. These are the people with their boots on the ground, researchers, journalists, advocates, gathering that really up-close local data through things like field notes, photos, and interviews. And here is a perfect and, frankly, life-saving example. Picture it, London, 1854. A terrifying cholera outbreak is sweeping the city, and no one knows why. So this one physician, John Snow, he starts mapping where every single person died. And his map revealed this shocking cluster of deaths all centered around a single water pump. Boom. He proved the disease was in the water, saving who knows how many lives. That is the power of one person with a map. But look, an individual can only cover so much ground. To get that huge, big picture view, you have to go to the other extreme. And that's where the organizational architect comes in. We're talking about the giants, governments and huge private companies with the resources to collect data on a massive, even global scale. I mean, just look at this number, over 331 million. That's not just some random statistic. That was the population of the United States from the 2020 census. And think about what that one number does. It determines how many representatives each state gets in Congress. It directs where billions of dollars in federal funding for schools, roads, and hospitals will go. The scale is just mind-boggling. And, of course, it's not just governments. Remember that traffic jam from the beginning? That's where we come in. That info comes from private companies using crowdsourced data. Basically, your phone, my phone, and thousands of others are all anonymously reporting their speed and location. When a bunch of us slow down in the same place, voila, Google Maps sees a traffic jam. We're all data collectors now. So we've covered data collection on the ground, from a single person to millions. But now, we have to zoom out. I mean, way out. Let's take a view from space, because this is where modern technology really changes the entire game. This whole world is called remote sensing, and it's pretty much exactly what it sounds like, sensing things remotely, from a distance. You can think of satellites and aircraft as our digital eyes in the sky, capturing information that's way beyond what we could ever perceive from down here. And what can these eyes see? Well, incredible things. They can track deforestation in the Amazon in real time, watch how cities grow and change over decades. You can even see a country's level of economic development just by looking at the lights at night. There's this famous satellite image of the Korean Peninsula, where you see South Korea just blazing with light, right next to an almost pitch-black North Korea. That one picture tells such a powerful story without a single word. Of course, the remote sensing tech we all use every day is GPS. It's really just a masterpiece of timing. There's a whole network of satellites orbiting the planet, constantly beaming down signals. Your phone's receiver just needs to hear the signals from at least 4 of them, and by calculating the teeny tiny differences in the time it took each signal to arrive, it can pinpoint your exact location on Earth. It's pretty wild.
Okay, so we've got all this incredible data. We have stories from the ground, massive census numbers, and images from space. It's a lot. How do you make sense of it all? The answer is something called Geographic Information Systems, or GIS. This is the brain of the whole operation, the powerful software that lets us combine and analyze all these different data sets together.
And honestly, the best way to understand GIS is to think of it like digital tracing paper. You can take different maps or layers of information and stack them right on top of each other to discover patterns you would have never seen otherwise.
Let's walk through a quick example. Let's say you're an environmental planner. So for your first layer, your first sheet of tracing paper, you map out all the sensitive wetland ecosystems in your region. Okay, you've got that? Now, you grab a second digital sheet, and on this layer, you add the locations of all the industrial factories in that same exact area. And now, here's the magic. When you overlay them, when you put the factory map right on top of the wetlands map, the GIS instantly reveals the relationship. You're not looking at two separate maps anymore, you're seeing a brand new story about risk. Now you know exactly which ecosystems are most threatened, and that insight can drive policy and lead to real-world action. Which brings us to the final and really the most important point here. All of this data, all of this amazing technology, it's ultimately about one thing: solving problems with maps. And this isn't just theory. It is the invisible engine of our modern world. In public health, it helps us track disease outbreaks, just like Jon Snow did. For environmental management, it helps us monitor our forests and our water. Urban planners use it to design safer intersections to reduce traffic accidents. It's even used to help ensure fair political representation. This data is literally woven into the fabric of our society. So, from the GPS in your phone to satellites watching over entire continents, our world is being measured and mapped more precisely than at any other point in human history. That gives us an incredible power to understand, to predict, and to shape our planet. And so, the question that leaves us with is, what should we do with that power?